So I'm going to start off by telling you a short story, and then I'll tell you a bit more about what I'm going to talk about today. So about 5 years ago, there was a case, 2 cases, in fact, in America. There was a girl who just turned 18, and she stole a bike. She made a rash decision. She saw a kid's bike in someone's front yard, and she picked it up and she started to steal it. But as she started to get down the road, she realised this was silly. The bike wasn't even her size. So she put it back. But the police had already been called. Now that bike was worth about $80 and she pled guilty to attempted thievery. But there was someone else on exactly the same day who committed another crime, committed robbery of a hardware store, which in America is where they sell like tools and things like that. And this guy actually had a weapon. He had a history of armed robbery, but he stole about $80 worth of goods. And the reason this is interesting is because they both went to court on the same day. And in many states in America, the judge receives a report, a sentencing report. And part of this report is generated by an algorithm. And the algorithm is predicting the likelihood that the defendant will commit a violent crime within 2 years. Now, in this case, the algorithm said she was likely to commit a violent crime, the girl that stole the bike. And he was not, the guy who had a history of armed robbery. So she went to prison, and he didn't. And he committed another violent crime very soon afterwards, and then he went to prison. But she was in prison. She had no opportunity to prove that she wasn't going to commit a crime. Because when a computer says no, it can be very difficult to argue with it. So I'll come back to why that happened and a bit more about that story later on. But just to introduce myself, my name's Adam Smith. I'm CTO of Dragonfly, which includes Piccadilly Group, which is a testing consultancy in the UK primarily, and Piccadilly Labs, which is a data science and AI engineering firm. So I've done a lot of work with AI, and in particular testing AI. And bias is one of the biggest quality issues that AI faces today. And I'm going to talk you through this, a few things. I'm going to talk you through why it's a problem. I'm going to talk you through some examples of it really causing some very interesting and very headline-grabbing problems. I'm going to talk to you a little bit about what the industry is doing, and also some of the testing approaches that you can use in this context. So I'm also part of the IEEE's Ethical Design Standards group. So those of you who are my age and in software testing may remember studying IEEE glossaries and definitions and things to get our first testing qualifications before the ISO standards came along. So I'm involved in that, looking specifically at how we test for bias. And I'm also involved with ISO on their AI committee, looking at all sorts of AI practices and how they can be standardized around the world. And also, from a testing perspective, I work quite closely with the British Computer Society. So, let's start with the obligatory definition of AI, because it's very hard to define. There's an argument on Twitter going on at the moment with some well-known testing personalities about whether the Boeing 737 disasters is actually an AI-related disaster. Because you can argue that where a machine is taking decisions away from humans, that's effectively becoming what a lot of people define as AI. Another way of defining it is by its research goals. So up here on the screen, some of the things you'll associate with AI, its ability to do things in the real world, to see, to drive cars, to automate processes, to move robots. Its ability to model things and predict things and learn. Its ability to talk to people like it is a person, the perception that it is a person. Its ability to do things like make complex predictions that humans can't. Ultimately, AI is statistics. Ultimately, AI is about correlations, so it is inaccurate. The question is whether it's more accurate than a human given the same situation. Applied to the Boeing 737 example, we think not. applied to many things in our day-to-day lives, whether Google's giving us search results or Amazon's predicting our next purchase. It is a lot better than a human and a lot faster. So why is there all this focus on AI? Because there hasn't been any huge research, significant leaps forward in the past few years. In fact, research on AI has been declining significantly since 2012. But the reason that we're seeing so much focus on it is really about data, so the prevalence of data. So IBM said they said 2 years ago that 90% of the data that existed in the world had been created in the last 2 years. And that statement itself was 2 years ago, so who knows what it is now. We have the volume and variety of data flowing around the internet that we've never seen before. Compute power. So these days, you can go to AWS, Amazon Web Services, and you can immediately provision thousands of servers, potentially with specialist processing units designed to do complex statistical calculations, GPUs. You can even, if you don't want to build your own servers, you can use AI as a service from Microsoft, Amazon, etc. There's been lots of things in the press about Amazon's facial recognition, and in fact, how poor that is. So now AI is becoming something that you don't have to be a specialist to integrate with your software. You just have to do a short training course in how to leverage these online services. But the biggest leap forward has really been the adoption of machine learning. Machine learning, which I'll define a little more in a minute, is essentially the ability for computers to learn from data instead of specific algorithms. But there's a problem here, because the AI that we're faced with right now is really narrow. So we're able to define AI to solve a very specific problem. We're not able to generalize up and use AI to solve general problems. 7, the unit in it that made the decision to push the plane down, if we call that AI, we need to be cognizant that it wasn't able to understand the consequences of what it was doing. So it isn't AI that's able to understand, think, and think outside of its specific scope. If you look at Amazon Alexa, this is really obvious. So I don't know if anyone's ever coded any Amazon Alexa skills or intents in the room. But what you essentially do is you are essentially designing an AI that knows how to do a very specific thing. So you might code into the Amazon Alexa framework, play a song. It doesn't understand all the different intricacies of how you might want to play that song, the things you may want to ask about it. It's literally just reacting to the word play. And when you string together thousands and thousands of these little narrow AIs, you get the perception of general AI. So Alexa feels like you're talking to a person to a degree, but you really aren't. And this is very important because this is significantly affecting people's perception of, a gap between people's perception of the quality of AI and what it can actually do. In this age, we need to be quite careful about what we delegate to AI. So machine learning is a field of computer science that gives computers the ability to learn rather than being explicitly programmed. Has anyone ever seen any machine learning code written in, say, Python or any other language? Yeah? It's very short, right? It's just a few lines of code, maybe even 2. There's not a significant degree of people writing in how they want the system to behave. So it does this by training the system with data. So that data becomes crucial to how the system works. It also infers absent attributes. The data that it's using doesn't have to be in the input data set. Machine learning algorithms can make inferences based on correlations. I'll give some examples of that a little bit later on. And what can it do? It can classify things, it can group things, it can count things. There's different algorithms that do slightly different things, but that's what it does. So this is very different from traditional software development, partly because we're using data rather than code, partly because it's black box. We don't necessarily understand everything that's going on in that algorithm. Sure, we can start to try and explain things by putting different data into it and observing the results. There's various different algorithms upon algorithms that will run on other algorithms and help you identify what the cause is of certain outputs. But those technologies are very immature, and the more we use things like deep learning and neural networks, the less effective those algorithms become. The other thing that's interesting about how people develop machine learning is they don't start with a hypothesis like you would in a scientific experiment or a testing experiment or even software development. They start with a set of data and they figure out what they can correlate, which makes a very imperfect solution. And a couple of things that are very important here to understand are, first of all, that the more you try and solve bias in a machine learning algorithm, the more you can introduce other problems. You can introduce problems where the machine learning model becomes incredibly sensitive to a very small number of data items in the input. This is called the bias variance trade-off. So the more you reduce bias, the more you can end up with other quality issues. There's also something which I won't go into detail on called the no free lunch theorem, which explains that any general purpose algorithm, its efficiency, its accuracy, when averaged across all possible problems, is equivalent. It's equal. There is no perfect algorithm that can deal with any problem. And these are the root causes of why we are 30, 40 years away from the AI that's described in sci-fi books, in things like the Culture series. So what am I getting at? What's the problem here? So AI technology is moving forward really fast, particularly the implementation of it by businesses and developers. But it can't transfer high-level knowledge between contexts. It just can't do it. Decades away. Humans, we know, have a set of moral values, and those values cannot be codified in an algorithm at present. Machine learning algorithms basically work by identifying patterns in data and using those patterns as heuristics. So heuristics, also known as rules of thumb. So we use these every day. These are performance hacks. We see something, we hear something, we make judgments. That is our brain bypassing all the necessary explanation and thought processes it would have to go through to come to a decision and making a draft decision, if you like, an in-principle decision. So we use these all the time. But when you put together machine learning and data about people's identities, you get some really unique and interesting ethical risks. So why are we suddenly all talking about ethics in software? This is new. A few years, I noticed there's other talks today about testing ethics. When people talk about AI, one of the first things they talk about is this, and they talk about something called trustworthiness. This really stems partly from data privacy concerns. So over the past 2 years, particularly in Europe, we've seen a lot more concern about data, people's data, and what other companies' systems are doing with that data. A lot of governments, a lot of organisations, a lot of companies recognise that the next level of this software ethics debate is really about how much people trust computers. And so there's a lot of focus internationally on looking at these issues, and bias is one of the key issues within that. There's others. I mean, people talk about Asimov's laws and things like that, laws that govern how AI will interact with people and how it will look at their safety and things like that. But what I'm really talking about today is the decisions and recommendations coming from machine learning based on people's identities. I think we'll start to see these things become non-functional requirements. So if you think about a functional requirement, you can decompose it into how different components will deliver on that functional requirement. Something like security, something like performance is an emerging property of the overall system. And I think we will increasingly start to see some of these human characteristics starting to become qualities of software that we see out there. And much like security, it's not just about technical activities, it's about organisational processes, governance, risk assessment, risk mitigation, quality risks, all the things that we think about when we're putting together things like test strategies. So let's talk a little bit more about what I mean about bias. So here are a few types of bias. There are at least 15 different types of bias that can be identified as applying to machine learning. But here's some really key ones. Selection bias. So selection bias is introduced when the training data, so the data that's used to train a machine learning model, is skewed, incomplete, or biased towards frequencies that don't occur in real life. There's a more mathematical definition in terms of whether the differences in the data set are systemic or randomized. And there's other definitions that are used by sociologists when they talk about things like sociology experiments and how they do experiments with people and how they behave in real life. But what I'm talking about here is essentially whether data that the developers had isn't representative of the data in production. It's that simple. Confirmation bias is another kind of bias, so you'll be familiar with this as testers, because this is one of the main reasons why independent testing is recommended, because a developer will confirm that the software works as they expected it. Similarly, when a data scientist is working on a model, they have preconceptions in there. They're going to validate their own preconceptions as they build that model. In fact, the risk is arguably increased. Training bias occurs when humans interfere, so where adversarial actors, bad actors, use an AI with bad intention. So Microsoft's Tay-bot a few years ago was fed, or it was a Twitter natural language bot, and some people decided to try and force it down their own in terms of their political views. And within something like 24 hours, Microsoft had to take it offline because it was spewing racist bile. What we're really concerned about, though, from a testing perspective, is bias that stakeholders don't want. Inappropriate bias that might have a negative impact on people. And by stakeholders, I don't just mean the people paying, I mean the people using the system, and I mean the people who are impacted by the system. The interesting thing about bias is it can arise at different stages. So it might be that you have to look at the data set that you're training with, take it right back to how that data was collected. Maybe that data was annotated manually. Maybe someone sat there and went, this is a picture of a cat, this is a picture of a dog. And they did it hundreds of thousands of times. And that labeling process, in itself, there could have been bias. It can also be introduced in the development process. It can be introduced actively in the testing process, and of course in production. So let's talk about some examples, some real-life examples that have hit the press. So this one is a guy in New Zealand who wanted to get a passport. So he uploaded his picture to the website from the Passport Authority and said, can I have a picture? And it said, the photo that you want to upload does not meet our criteria because subject's eyes are closed. So this is a perfect example of software that's looking at people's faces, and the test data they've used isn't representative of everyone they've got in their country. And there's loads of examples, loads of these. Here's another one. So researchers found that Google was essentially promoting job adverts that paid a lot to men, not women. And this is a really interesting one, because analysis then showed later on, which Google were involved in, so I don't know how much to trust it, but the analysis showed that Google said, well, they click on them more. Men tend to want to get out of their comfort zone, and they're more likely to apply for jobs outside of their skill set and more senior than they're actually qualified for. And that's why men see jobs that pay more. So it's an interesting trade-off there, isn't it? Because how did Google react to that? Here's another one. So this is spatial tracking. So they've shown that if you are black, then devices that track your face movement in video and things like that are essentially less effective. So this all comes down to data. So throwing more data at the problem can sometimes solve the problem. Research has shown that every time you double the data, you reduce bias by 4 times. But you can't just take data from the internet, because the internet's already got all this biased data in there. Look at, if you put CEO into Google Images, you're going to see a whole load of white men with one or two exceptions. So a model that's using things like correlations is going to start to make inferences based on that. This isn't shown very well on this screen, but these are two examples where people have used internet-found data. So they've done things like word association, that's associated names of people from particular ethnicities with unpleasant adjectives, and people from certain other ethnicities with positive adjectives. This can be indirect. I mentioned before that the data item doesn't actually have to be in the inputs to the software. So this is my Twitter profile. So Twitter thinks I'm either between 13 and 54 or older than 65. Something I've tweeted has made it decide I'm definitely not between 55 and 65. Who knows what? And inferences like that can be made by software all over the place. Staples is a great example. I don't know if you have Staples in this part of the world, but Staples sells stationery, computers, office supplies and things like that. And they decided on their website they were going to offer people discounts if they lived near a competitor, which is completely sensible. Everyone can see why they would do that. But what actually happened was that because their competitors were in richer areas, they ended up offering higher prices to people who had less money. And of course, the press got hold of this. Staples changed their policy very quickly. Amazon. Bloomberg analysed Amazon's same-day delivery and Amazon Prime, and they just weren't offering same-day delivery in predominantly black zip codes in the US. And Amazon doesn't ask you for your ethnicity or your race. It's inferring variables based on things like your zip code. And you can counter-argue this. You can say, they're Amazon, they're doing delivery. Like, surely they can choose where they do delivery, right? But within days, they corrected this problem. So UCAS. UCAS in the UK, they manage university applications and the process of people applying for universities. So they found that you are significantly more likely to be identified as a fraudulent applicant, many times more likely, if you are black or from a minority ethnic community. And nobody's solved this yet, because it uses free text. Nobody's actually figured out why this happens. They've done a whole inquiry into it, still haven't figured it out. Facebook are actively patenting and working on how to predict how much money you've got based on things you do on Facebook, because that's pretty valuable to advertisers, right? They're obviously not asking you, are you rich or poor? They're predicting it based on what you do. Recruiting tools. So recruitment is a horrible area, in some ways, to use AI. Because if you think about, as a hiring manager, one of the things you're always trying to do, or trying to not do, when you're hiring, is hire people like you. But if I put a machine learning algorithm and I say, who should I hire for this job? It's going to base it on past successful hires. So it will propagate whatever the culture and makeup is of the existing teams. So Amazon ditched that. And there's a whole ethical question here. What happens when these algorithms have the potential for good? So in the UK currently, they're sucking in all sorts of data from criminal records, from your housing, your tax records, and using it to try and predict whether you will abuse your children. So going back to the example that I gave at the start, in the US, they get these reports, these sentencing reports. So the girl in the story was black, the guy was white. And the system doesn't include race, so it's inferring it from other variables. But when you break down black defendant and white defendants' risk scores on average, you can see a massive disparity in how they're predicting risk. One is high risk. And this is because of something called Simpson's paradox. If you look at a load of data, and look at how it's distributed across people, you may see that it's distributed in a very fair way. But until you divide things down by different subgroups, whether it's race, gender, shoe size, zip code, height, you don't see the imbalances and the disparities in the data. And that's one of the key things to testing for this. Here's some of the areas, and this is a report from the French data protection authorities. Here's some of the areas that machine learning algorithms are being used now in order to make decisions about people. And these range from predicting crime, identifying criminals from facial recognition in a crowd. They did this in the UK. They took a laptop and they pointed it at crowds of people, and they ended up detaining 100 people and searching them because they believed they had outstanding warrants. But actually, only 10 of them did. So 90% error rate. So just to recap quickly, machine learning is an important part of AI. Its use is booming. Where personal data is processed, there is a risk of bias against people, which can be very, very embarrassing for companies. Protected features, so features about your identity, don't need to be explicitly included in order to be used. Bias can emerge not only where the data set doesn't reflect society, but where there is accurate bias in society already. Going back to putting CEO in Google Images, that bias already exists in found data on the internet. You can take existing prejudice and put it in a machine learning algorithm. It's like money laundering for prejudice. So, testing, because I've only got a few minutes left. So, ISO 2510 talks about product quality. Now, there's a range of proposals for additions to this framework to deal with AI. Now, some of them I don't agree with, some of them I do. But one of the most important, I think, is trustworthiness. There's a couple of others around how well the AI can learn, how well it can generalize, but trustworthiness is going to be one of the key things that companies are looking to demonstrate in consumer-facing AI. Are people really testing for this? Is this real, or am I just talking? Yes, they are. This is a system in London that I submitted a Freedom of Information request. So in the UK, I can ask the government anything, and they have to answer within 4 weeks. And they are doing it. I've submitted quite a lot of these. Companies are starting to do this. They're starting to execute this testing. The industry is starting to respond. Google, Microsoft, IBM have all launched tools in order to test for this. What these tools do, essentially, is they look at the data and they break it down in visualizations. So you can pivot on different characteristics about people and determine whether the algorithm is biased against them. Some of the more advanced tools allow you to actually go and pull in all your testing data and training data and compare them to production data to start to analyze it and tell you why this is happening. So how do we test for it? So at the moment, there are only 3 identified ways to test for this. One is the most obvious. You have gender going into an algorithm. Change the gender and see if the actual result changes. That's the most obvious one. But actually, that doesn't work very well, because these systems are not deterministic, they're probabilistic. So even if you change the gender and you get the results that you think is fair, it might, on another record, have a very different result. So testing just on a few records doesn't really tell you much. Group discrimination is easier to measure, so where you're able to look at outcomes for each subgroup of people, but you don't necessarily have data about people. You don't necessarily know their race, their ethnicity, your gender. So this gets quite complicated, because maybe you need to get some really sensitive data in your test environment. Or maybe you need to use what's called an external validity test, so going to things like census data. So the reason that people detected the problems with Amazon and Bloomberg was because they correlated zip codes with the census. So using census data and correlating that with test data. It's not easy to do. And how should this be applied? So, much like any other software development process and software testing process, you have to start off with who are your stakeholders, who are the people that might be affected by the system, that might care about the results. You have to look at the risk and impact. What is the risk? Is this a pocket calculator? Probably not really much risk here of bias. But a system that uses people's personal data becomes increasingly high. And when it actually starts to have vital and significant legal effects on people, like they're being sent to prison, it becomes very significant. And in fact, these risk assessments and the testing are a legal requirement in many European countries now. Think about your tested diversity. There's all the same group of people looking at this problem. It might get different results if you diversify a little bit in the people you're using to talk about it. A bunch of white guys in a garage in San Francisco seem to churn these algorithms out quite a lot, so it's not surprising that we get some results that we're not expecting. This is an example where using production data is probably a really good idea. It's going to give you a much more accurate spread of data. Think about statistical techniques, and data scientists can help with this, how you can compare your test data to see how representative it is with what you're seeing in the wild. Think about acceptance criteria. In many of these examples I gave before, there's potentially businesses could have made the other decision. They could have said, actually, this is operationally acceptable. We've made a decision not to deliver to these areas. In the test planning stage, you essentially need to build tools and things like that, because this testing is incredibly difficult to do manually. In the test execution stage, think about independence as usual, independent testing to avoid confirmation bias, and think about how you're going to get the sign-off if you do find bias. That's key. And then finally, you have to keep testing. Models often continually evolve. Society changes. People care about different things culturally in society. And people can interfere with your system and try and inject bias. So that's it, and I'm to time, I think. We've got a few minutes for questions. We've also got a free t-shirt for the best question. So I'll open that up to the room. Hi.
Hi, I'm Daria Lashkevich from Accenture. Thank you, Adam, for a very interesting topic. And my question is like that. Maybe you hear about some machine learning application which can generate fake news.
Mm-hmm.
Yeah, and what should we do if the target of such machine learning application to create bias to something, just to create some provocation? How we can recognize it? Maybe you know how we can solve this problem.
You're from Accenture, did you say?
Yes.
So I should mention Accenture also have a tool for testing for this. I just haven't added it to the slide.
Yeah,
no. But your question is, how can we detect bias in fake news?
Yeah.
And this is a real problem, because over 450 articles just in the Washington Post last year were written by AI, not by a human journalist. There's all sorts of risks around this. I'm going to say I have no idea. Because what you're dealing with there is you're dealing with some very abstract concepts and free text. I'm not aware of any industry approaches to this at the moment, only a few scientific papers.
Okay, thank you. It's a field to work, actually.
Yeah.
Thank you.
It's Florian from Transylvania. Unfortunately, I can't stand up because I have a cast. I have a fairly interesting, more testing bias, or more of a bias-related question. For instance, technology is usually a good tool for globalization. So something that you invent that can be used in different areas is a global product. But for instance, a lot of the companies or a lot of the ideas that are coming from specific countries, or let's say specific people that have specific culture. These can tend to influence countries or areas that don't have that strong culture, for instance. Is this something that is considered when this is being done? So for instance, let's say I'm from Romania.
Mm-hmm.
Our culture isn't that well known in the world, but our culture is influenced by what we see outside. And something that is appropriate there cannot be appropriate here. But we kind of have an internal filter. Do you guys have this?
Yeah, so a couple of things. So, yeah, absolutely, culture and geography is a huge problem. If you test for the US and then try and do it in the UK, you'll have very different results. But the other part of your question is really about how can culture be absorbed by AI and AI development processes, I think, which is a really, really good question. So one of the things I do know about is work around storytelling and getting people to tell stories to AI in a way that allows culture to be absorbed. But these are very ephemeral activities. I'm not sure how successful they'll be. I think that is the nub of the problem is culture. That's the nub of the problem, because people all over the place have different cultures, they have different things that are important. If you look at the rollout speed of Amazon Alexa, and I don't think it's available in Russia, it took them years to get it working in the US, it took them several years to get it working with the UK, and then it took them another year to get it working in Spain. And that's because of the differences in culture, but also language. These things are hugely geographically dependent.
Hi, thanks for the talk. One question, maybe from your practical experience, is it possible if you come in late as a tester to basically revert the biases, or is it something which you, by enhancing other rules, etc., new training data, or if the algorithm has gone and progressed for a certain time, basically need to start from scratch?
Yes, it's possible. There's a number of ways you can do it. So the primary way is to change the data that's being fed into the development process. There are other more mathematical ways that a data scientist would use, but those mechanisms are actually more risky because they can actually have the opposite effect to intended and introduce bias in. If you're trying to counter for one type of bias, they can introduce bias elsewhere. But if you're coming into it as a tester, absolutely it can still be changed. Even if the product is live, if you're identifying these problems and then the business genuinely wants to solve them, they can be solved.
Time for more questions.
Hi, my name is Olga. I'm working in Riga, a genetic testing company. I'm QA. I just have a thought. What do you think? If AI could be teaching on the isolated balanced group to avoid racist bias, and could it teach AI to be more tolerant?
Sorry, can you say that again?
If you're going to teach AI on balanced group to avoid racist bias.
So I don't think you can tell it not to be racist. I think you have to change the data that's going in there. I don't think that kind of technology exists within AI at the moment to give it that value, because that's really a value-based judgment. It's only really capable of using ones and zeros, essentially. Everything that goes in, even when you take in data like race, it's just turned to a 1 or a 0 before it hits the model. Doing that kind of thing is yet to be mastered.
So if AI is so young, maybe we should teach him like a child before it can be acting like an adult?
Yes, a small child that will take a long time to grow up, I think.
Yeah, something like that. And understand what is tolerance, etc. Okay.
Other questions? No, Michelle?
Hi, my
Hi.
name is Olga. I wanted to ask, it takes a lot of time to learn a system, but how much time do you need to test the system? You also have to learn your testing system somehow. So how can you compare the process of learning your real system with the process of learning your testing system?
Do you mean the process of learning production system versus your testing system?
Yeah, so how much time does it take to learn your testing system in order to test your production system?
Yeah, I mean, it takes much longer because typically there is change, you have to learn about new features, and typically it's changing a lot while you're learning about it. But I think that's true of any testing or production system. I don't think it's different necessarily with AI systems, although you do need to get to that level of understanding of some of the issues like this. As testers, we're always focused on what can go wrong, and the things that can go wrong with AI systems are different. Does that answer your question?
Well, I wanted to know, does it take more time to learn a testing system than the system, production system itself, or not?
No more than with traditional software.
Okay, thanks.
Time is up, so thank you very much.
Thank you for listening. Any questions? Any other questions will be around the conference all day.